In topic 2, we are being introduced to fractional exponents, meaning we are going to have exponents, but now those exponents are fractions. So let's see what that does to our number. If we have a fractional exponent, so let's look at this one over here, x to the power of 1/2 or 1 over 2. We look at what the denominator number is. So in this instance, the denominator of the exponent is 2, and that number becomes the index of our radical. So let's go through this chart here so we could see this further. So if I were to take this 1 to the power of 1/2, what we would do is we would put that 1 under our square root sign, and now this denominator of 2 turns into the index. So we are taking the square root of 1, which is 1. If we're looking at this next one here, again, we're going to have 2 as the index of our radical. So I'm going to put a 2 here, square root sign, and then that 4 goes underneath the radical. So we have the square root of 4, which is equal to 2. And again, we're going to do this with the 9 and so on. So I'm going to fill out this chart here, then we'll come back. All right, I filled out this first chart here, and now let's take a look at the second one. Second chart's the exact same thing, except now we are going to take the cube root of numbers, because now that denominator in the exponent there is a 3. So that's going to turn into our index, meaning we are going to take the cube root. So if we have 1 to the power of 1/3, we are going to turn that into the third root of 1, which is just 1. If we do the same thing with the number 8, we would have 8 to the power of 1 over 3, which turns into the third root of 8, which is 2. So I'm going to continue filling out this chart as well. Okay, so I finished filling out this chart here, which just resulted in us taking the cube root of all of these numbers here and getting these answers. So let's look at some other examples here. Example 1, evaluate each power without using a calculator. So now all of these powers are fractional exponents. So starting with A here, I'm just going to separate them. I'll zoom in. So let's start with A. We have 27 to the power of 1/3. So remember, the number on the bottom turns into the index of the radical. So we're going to have the third root of 27. And we know the third root of 27 is equal to 3. So that's our answer for this one. For B, we have 0.49 to the power of 1 over 2. So this is going to turn into this square root of 0.49, which is 0.7. And I won't give you very many decimals on the test. I don't even know if I'll give you any decimals on a test. Next, we have negative 64 to the power of 1 over 3. So we're going to put that little cube root sign there, and we're going to do the cube root of negative 64. So this one we might have to think about. What number times itself 3 times equals negative 64? So our answer this time is negative 4. And that's because negative 4 times negative 4 times negative 4 is equal to negative 64. And now this time we have a fraction that has a power that's a fraction. So let's see how this is going to work. So we're going to treat this one exactly the same as we treated the other ones. So let's put this entire fraction here, the 4 over 9, under the square root sign, because our denominator is a 2. So we have the square root of 4 over 9. And let's think back to grade 9 when we did this. What happens when we have a fraction under a radical sign? Well, we can just split up the radical sign for the top number and the bottom number like so. And now this question's really easy. We know the square root of 4 is 2, and we know the square root of 9 is 3. So that's our final answer there. Now in example 2, we are going to be looking at fractional exponents that now have a different number on the top. So let's see what happens when we have a number in the numerator as well as in the denominator. Well, the number in the numerator is going to be treated like a regular exponent, like a regular power. So if we were to write 40 to the power of 2 over 3 in a radical form in 2 ways, here's 2 different ways we could do that. So one way we could write this is, well, we know the index is going to be 3, so I'm going to be doing the third root of 40, and then I'll put that little squared sign under here. So it's actually the third root of 40 squared. So remember, the numerator is just like a regular power. So 40 to the power of 2, and then we're taking the cube root of that. Another way we could write this is we could do brackets like so. We could do the third root of 40, and then all of that squared. So the difference between these two is just the order you would do things, but it won't change your answer. So in this case, we would do everything in the brackets first. So we would start by taking the third root of 40, which I don't know off the top of my head. And then we would take that answer and we would square it. And that's following the order of operations. For the first one here, we don't have any brackets, so the thing we would start with is the exponent. We would do this first, so we would do 40 squared, which is going to be 1600, and then we would take the cube root of 1600 and get our final answer. So there's two different ways we can solve these things, but you will get the same answer either way. The difference is sometimes it's easier to do one thing than the other, and we'll see that in some examples we look at. If we're looking at B here, it wants us to write both of these in exponent form. So let's start off with the first one. So this is the square root of 3 to the power of 5. So remember, if there's no number over here, that means there is an invisible 2. So that means our denominator for our fractional exponent will be a 2 and the numerator will be a 5. So if we were to write this, it would be 3 to the power of 5 over 2. For the next one, it's written in this other form with the brackets, but we're just going to do the exact same thing. So again, we have an index over here, and that is 3. So that means our denominator is 3, and our numerator is going to be 2 of our fractional exponent. So we're going to have 25 to the power of 2 over 3. So now let's actually evaluate some of these here with fractional exponents. Now I will give you a warning that some of these questions in our notes do require a calculator, but I promise you on a test I will not give you any numbers that you can't do without a calculator. So let's start off with A. We're looking at A here. We have 0.04 to the power of 3 over 2. So let's write this in our radical form. So the bottom number here is going to be the index. So we're going to have the square root of 0.04 to the power of 3. Now you can either take the square root of the 0.04 first, or you can do 0.04 to the power of 3 first. So the way I'm going to solve this one is I'm going to start off by doing the square root of 0.04 first. So the square root of 0.04 is 0.2, and then we still haven't dealt with that power of 3. So now we have 0.2 to the power of 3. And if we were to continue doing that, 0.2 to the power of 3 gives us 0.008 as our final answer. For B, we have 27 to the power of 4 over 3. So now let's turn that into a radical. We're going to have the third root of 27 to the power of 4. Now it's up to you if you want to do the third root of 27 first, like that, or if you want to do 27 to the power of 4 first. Now this is where that decision matters on a test, because I know what the third root of 27 is. I know that's 3, but I have no idea what 27 to the power of 4 is in my head. So if I had this question on a test, I would do the route that I know. I know the third root of 27 is 3, so I'm going to do that first. So the third root of 27 is 3, but I still haven't dealt with that power of 4, so I'm going to write that right there. And now I know that 3 to the power of 4 is equal to 3 times 3 times 3 times 3, which is 81. So that's our final answer for this one. If you did 27 to the power of 4 first over here, you would still get the same answer, and then you would have to third root it. You would still get 81, but you might not be able to do that in your head. You might need a calculator for that. Let's look at C. We now have a negative number, negative 32, and we also have a decimal exponent. So this one gets a little bit more tricky. We need to convert that decimal exponent into a fraction. So let me just write down the question. We have negative 32 to the power of 0.4. Let's change that decimal into a fraction. So if you remember our place values for decimals, we have tenths, hundredths, thousandths. So here we actually have 4/10, so we can rewrite this as 4/10, like that. And I can actually reduce that fraction, so we have smaller numbers we're dealing with, because 4/10 reduces to 2/5. And now this is a little bit easier for us to work with. So now let's move this into a radical form. That would be the 5th root of -32 to the power of 2. So again, I don't know what -32 to the power of 2 is in my head. I'd have to use a calculator for that one. So I'm going to start off with doing the 5th root of -32. So the 5th root of -32 would be -2. And then we still haven't dealt with that squared over here. So now we're going to write the squared over here. And we're going to do -2 squared, which is equal to 4. So that's our final answer for that one. And finally, for D, we have 1.8 to the power of 1.4. So again, we have a decimal as the exponent, so I'm going to switch that into a fraction. So I have 1.8, and this time I would read this as 14/10. So I'm going to put 14/10 here, and we can reduce that to be 7/5. So now let's do the 5th root of 1.8 to the power of 7. And this one I for sure need a calculator to deal with because I don't know how to do this one in my head. So because we haven't taken this route yet, let's do 1.8 to the power of 7 first. So that means I'm going to write my answer underneath this radical sign here. So 1.8 to the power of 7 is 61.22. And like I said, I needed to use a calculator for this one, so I would not give you this on a test. And now I would do the 5th root of this number here. So the 5th root of 61.22 is equal to 2.28. And that's our final answer. If you did the 5th root of 1.8 first, so if you did this first, instead of that power of 7, you would still get the exact same answer. Finally, moving into example 4, we have a word problem. So this one here, you also need a calculator for. So this one here, part of it needs a calculator and part of it doesn't. So I'd say this one would be no calculator, and this one would be calculator. And you'll see when we go through the calculations why that is. Now, the word problems can be scary, but they're actually really easy. All they're doing is they're trying to connect it to other subject areas, and all we have to do is plug numbers into a formula and solve using BEDMAS. So let's see here. Biologists use the formula B is equal to 0.01 m to the power of 2/3 to estimate the brain mass, B kilograms, of a mammal with body mass m kilograms. Estimate the brain mass of each animal. Okay, so in this example here, we have a husky with a body mass of 27. If we look at our word problem here, it says body mass is represented by the letter M. So we have body mass equaling 27. So we're going to plug 27 into the formula where the M is. So I'm going to write B is equal to 0.01. M is 27 to the power of 2/3. And now if we solve this using BEDMAS, we would do the exponents first. So I'm going to have 0.01, and let's change this exponent into a radical. So we're going to have the 3rd root of 27 to the power of 2. Now I personally don't know what 27 to the power of 2 is, so I'm going to start by doing the 3rd root of 27. And the 3rd root of 27 is equal to 3. But we still haven't dealt with that power of 2 over here. So we're going to have 3 to the power of 2. And we still have that exponent. So if we're still following BEDMAS, we would continue with the exponent 3 to the power of 2, which is equal to 9. So now we have 9 times 0.01, and that's really easy. That would just be 0.09. So our final answer would be 0.09 kilograms. And I'm going to put a box around that. Try to get into the habit of putting the units there, so the kilograms, because we're answering a word problem here. So for B, We're now dealing with a polar bear with a body mass of 200 kilograms. So I'm going to write the formula again, but instead of putting m as 27, we're going to put m as 200 to the power of 2 over 3. So again, we're going to follow the same steps, 0.01, and we're going to do the third root of 200 to the power of 2. So I'm going to use my calculator for this one. I'm going to start off by doing 200 squared. So 200 squared is 40,000. So we're going to have 0.01. Now we haven't dealt with that third root yet, so we're going to have the third root of 40,000. And now I don't know what the third root of 40,000 is, so I'm definitely going to use my calculator for that. 0.01, and that's going to be, the third root of 40,000 is 34.1995. And if we multiply these two together using our calculator once again, our answer would be 0.341995, or we can just round that to 2 decimal places, 0.34 kilograms. So these questions aren't hard, it's just letting us work with bigger formulas and implementing the skills we just learned.